Welcome to UKC Maths. Today I am going to discuss complex number theory. Once we complete this complex number theory, we will go through the problems or exercises associated with this topic on the interactive boards. In this lecture, I will discuss what is complex number. If you say mathematics as a toolkit, then this complex number is a very powerful tool of this mathematical toolkit. According to me, the best way to study not only this complex number but the whole mathematics or any topic is first go through the basic concepts or the theory associated with that particular topic. Once the basic concepts associated with that particular topic is cleared, your life will be very easy, your life will be very comfortable, at least in solving the problems or exercises associated with that particular topic. According to me, solving a problem is not a completely different task. It is merely an implementation of the basic concepts or the theory associated with that particular topic. Once you understand the basic concepts associated with these complex numbers, you will appreciate the beauty of these mathematical structures and all. Now let us proceed further. First go through this small PCM. Let us refresh your mood before moving forward to understand the basic concept related with these complex numbers and all. This is a cartoon type picture created by me known as PCM, picture that convinced me. So what is the first impression came in your mind when you listen the word complex numbers? We all know the literal meaning of complex is complicated, some sort of complication, but complex does not always mean complicated. Here we mean a number composed of two parts, two numbers, real and imaginary, clubbed together to form complex numbers, analogous to a building complex consisting of two buildings. Here real and imaginary are not very distinct structures and all. By a imaginary number we mean a real number multiplied by a special entity known as imaginary unit. If I am not wrong, this imaginary term was coined by the mathematician René Descartes. So imaginary is a historical name given to it, and there is nothing more than this. I would like to clear a small mess that there is nothing imaginary in this imaginary number system. They are as real as the real number system because they are fulfilling the gaps of numbers which were not fulfilled by the real numbers. That is where our real number system fails. So what was once believed as impossible, ridiculous, a mental torture, even fictitious or imaginary, has become a reality. Works on complex numbers led to the fundamental theorem of algebra and a very powerful branch of mathematics known as complex analysis. Now let us see the formal definition of a complex number. A number of the form a plus ib, where a and b are real numbers and I is known as imaginary unit and defined as a square root of -1, is known as complex number. A complex number is generally denoted by the English alphabet letter Z. So Z equal to a plus ib is the general form of a complex number. Here I would like to clear one thing, that there is no any compulsion to use the English alphabet letter Z to denote this complex number. You can use X, Y, U, V, W, whatever you like to denote a complex number. Here I would like to clear one more thing, that in some disciplines like physics, electrical engineering, electronics, control theory, symbol J or letter J is used in place of I because I is frequently used to denote the electric current. So the next alphabet to I is alphabet J. So the letter J is used to denote the imaginary unit in place of I. Now let us see, if Z equal to a plus ib be a complex number, then the first part, that is A, is known as the real part of the complex number Z and is denoted by REZ. And similarly, this second part, that is B, which is the coefficient of the iota term I, is known as imaginary part of the complex number Z and is denoted by IMZ. Thus, A equal to REZ and B equal to IMZ. So, the general form of this complex number in terms of REZ and IMZ can be written as Z equal to REZ plus iota times IMZ. Here I would like to clear one more thing, that whether you write Z equal to REZ plus I into IMZ or Z equal to REZ plus IMZ dot I, or in other way round, whether you write Z equal to A plus IB or Z equal to A plus BI, both are same. It doesn't matter because the complex numbers follow the commutative law. Now let us understand these simple concepts with the help of some small illustrations and all. Let Z equal to 2 minus 5i be a complex number. Then the first part, that is 2, is the real part of this complex number. So we can write REZ equal to 2. Imaginary part of this complex number is minus 5, that is IMZ equal to minus 5. Now let us take some another example. Z equal to minus under root 7i be a complex number. Then here the real part of this complex number, that is REZ, is 0, and imaginary part of this complex number, that is IMZ, is minus under root 7. Now let us have a look on this next concept. A complex number whose imaginary part is 0 is known as purely real, and a complex number whose real part is 0 is known as purely imaginary. Thus the general form of a purely real number is Z equal to A, and the general form of a purely imaginary number is Z equal to IB. For example, Z equal to minus 3 is a purely real number, whereas Z equal to minus 2i is a purely imaginary number. We have already discussed an imaginary number is a number of the form under root minus k, where k is a positive real number. Now let us have a look on this simple concept. If A and B are real numbers, then a square root of minus A into a square root of minus B is equal to minus of a square root of A into B. This is the correct identity or equation. This can be easily verified by using the concept of imaginary unit. A square root of minus A can be written as a square root of A into I. Similarly, a square root of minus B can be written as a square root of B into I, and when you multiply these both, you will find I square into a square root of A into B, a square of I is equal to minus 1, so this result is verified. But be careful, a square root of minus A into a square root of minus B can never be equal to a square root of A into B. So in this way, we have seen that this complex number system is the largest of all number systems. All other number systems are basically inherent in it. The set of complex numbers is denoted by the English alphabet letter C. So let us have a look on what we have studied till now. The general form of a complex number is Z equal to A plus IB, where A is the real part of this complex number Z, B is the imaginary part of this complex number Z, and imaginary unit or iota I is equal to a square root of minus 1. If imaginary part of this complex number Z, that is B, is 0, then this complex number Z transform into the form Z equal to A, which is a purely real number. And if the real part of this complex number z, that is a is 0, then this complex number transformed into the form z equal to ib, which is a purely imaginary number. Now let us have a look on this diagram. This diagram will give you an idea that where our complex number system stands. Here we have natural numbers or counting numbers at the core. If 0 is added along with these natural numbers, then it is known as whole number system and all. When whole number system is further expanded by taking natural numbers along with 0 and negatives of this natural number, therefore integer number system and all. When integer number system is further expanded, we have rational number system. You might have studied about this rational number system in our previous classes and all. Now let us recall that definition. A number of the form p by q, where p and q are integers and q not equal to 0, is known as rational numbers. We have one more number system known as irrational numbers. This irrational number is a completely different type of fellow due to its nature and characteristics and all what it possesses. The property of irrational number is that they cannot be converted into simple fraction. They are non-terminating and non-repeating and all. It consists of numbers of the form a square root of 2, a square root of 3, a square root of 7, transcendental numbers like Euler number e, pi, and golden ratio phi, etc. So what mathematician did that? They combined rational numbers and irrational numbers and gave a name real numbers. So real number consists of both rational numbers and irrational numbers. So this real number system is also one of the broadest number system what we have studied till now in calculus. They were real numbers and all. So from this diagram it is clear that this complex number system is one echelon higher than the real number system. That is, complex number system is the broadest number system. All number system what we have studied till now, all are within this complex number system, all are inherent within this complex number system. Thank you for watching UKSing Maths. If you wish, you can like and subscribe UKSing Maths, our YouTube channel, to stay connected with us. You are free to comment on the content of the articles and suggest any improvement if any. Your suggestions are always welcome and highly appreciated. Thank you.